Hello again, bakunzi ba Nage TV. As we are looking here, now it's time we are going to study about sum and difference formulas. From the next video, we have seen how we can prove that cosine of alpha plus beta equals to cosine of alpha times cosine of beta plus sine of negative sine of beta times sine of alpha. So now we are going to see how we can prove that sine of beta plus alpha equals to sine of alpha times cosine of beta plus sine of beta times cosine of alpha. Now let us start. So as we can see in this figure, sine of alpha plus beta would be given by the triangle ABC. Triangle ABC. So as usual, we know that sine of any angle equals to the opposite side over the hypotenuse. So we can say that, the hypotenuse is equal to the distance AB here, and the opposite side would be given by the distance BC here. So sine of beta plus alpha would be equals to opposite side, which is equal to BC, over hypotenuse, which is equal to AB. But also we can say BC is equal to BE plus EC. BE plus EC, right? So replace the value of BC in this formula so that we will get sine of alpha plus beta equals to BC, which is equal to BE plus EC over AB, right? So this would also become BE over AB plus EC over AB, right? So from this diagram we are going to see also BE would be equal to which value? So BE, distance BE, it is this one, BE, okay? BE would be equals to, well, we know that we have the relation here, the sine of beta, this angle here, sine of beta is equal to, as we have suggested before, it is equal to the opposite side over hypotenuse. So the opposite side of this angle beta is equal to EF, okay? EF, so it would be equal to EF over hypotenuse. The hypotenuse is equal to BF, right? BF, yes. So let's also calculate right. Let's also calculate the value of cosine of beta. Cosine of beta would be equal to the adjacent side. The adjacent side of angle B is the distance BE, okay? BE, right? Over hypotenuse. So hypotenuse is equal to distance BF. BF, right? BF, yes, BE over BF, right? So here also we can also say that BE is equal to make a cross multiplication, so we would get BF times cosine of beta, right? Cosine of beta. So I think BE we have seen it. So let's also calculate the value of EC, the value of EC. Now, as you can see here, EC is this one, distance EC. It is from E to C here. So, and this can be equal to FD. EC can be equal to FD, right? So and this can be well explained by sine of beta, this angle sine of beta, okay, sine of beta, which would be equal to the adjacent side, opposite side, right? Opposite side FD, equals to opposite side FD over hypotenuse. So hypotenuse, it is the distance AF, A to F, right? Okay. S over F, right? So this we have seen that FD is equal to EC. So this would become EC over AF, right? So I think here, as we can see, right, we can say that EC is equal to, make also cross multiplication again, is equal to AF sine of beta, right? So replace the value of the value of BE here, the value of BE, and the value of EC in its formula, here, so that we'll get sine of alpha plus beta, which is equal to BE, which is equal to BF here, BF times cosine of beta over AB here, AB plus AF or plus EC, right? EC, which is equal to EF, which is equal to EF times sine beta, AF times sine of beta over AB, right? Yeah. So this can be also written as BF over AB cosine beta plus AF over AB times sine of beta, right? So let's also calculate the value of sine of alpha and also cosine of alpha, right? So sine of alpha would be also given by opposite side, the opposite side of this angle alpha. I think it is the distance BF, okay, BF over hypotenuse, which is the distance BA or AB. So it means that it is BF over AB, right? And also for cosine alpha would be given by adjacent side of angle alpha, which is equal to distance AF, this one, okay? So over AB, hypotenuse AB, distance AB, yes. So it would be AF over AB, okay? So I think if you are looking carefully here, you would see that sine of alpha is equal to BF over AB as it is here, okay? And also cosine of alpha is equal to AF over AB, which is also here now, AF over AB. So at this point you can replace the value of BF over AB and AF over AB with each value, so that we would get sine of alpha plus beta, which is equal to BF over AB, which is equal to sine alpha times then cosine beta plus AF over AB, which is equal to cosine of alpha times then sine beta, right? So I think if you check at this original formula, this one, okay, and also to this one, you will find that it is looking the same. So if it is looking the same, we may say that our identity has been proven. So let's also see the sine of alpha minus beta, and I think this would be also the same as this one, as we are going to replace the angle. So this would be equal to, here the angle beta is negative, so we would write sine alpha cosine beta, which is negative, okay, plus cosine alpha sine beta, which is also negative. So this would be because cosine of negative angle equals to cosine of angle which is not negative, so we would write sine of alpha times cosine beta, right? Because cosine of negative angle equals to cosine of that angle which is not negative, plus cosine of alpha here, but sine of negative angle equal to negative sine of that angle, okay? So here we would have negative sine beta, right? So this would become sine of alpha cosine b beta negative, because of this negative obtained here, negative cosine alpha times sine beta. So I think this has also been proven. So let us see also about tan A plus B. So we know that tan A plus B is equal to sine of A plus B, right? Sine of A plus B over cosine of A plus B. Okay, because tan of angle A would be equal to sine of angle A over cosine of angle A. So if the angle A is equal to A plus B, so this value would be replaced by this one, so that we would have tan A equals to sine of A plus B over cosine of A plus B, right? So we have seen that sine of A plus beta, sine of A plus B, not beta, equals to sine of A times cosine of B plus cosine of A times sine of B, right? And also we have seen that in the previous video, we have seen that cosine of A plus B equals to cosine of A cosine of B negative sine of A sine of B, right? So replace this value in this formula so that we will get tan of A plus B will be equal to sine A cosine B plus cosine A sine B over cosine of A cosine of B negative sine of A sine of B, right? So divide cos A cos B on both sides, on the numerator and also on the denominator, so that you will get tan A plus B, which is equal to sine of A cosine of B over cosine of A cosine of B plus cosine of A sine of B over cosine of A cosine of B over cosine of A cosine of B over cosine of A cosine of B negative sine of A sine of B over cosine of A cosine of B, right? So at this point, I think you will reduce B cosine of B by cosine of B. cosine of A by cosine of A, and cosine of AB by cosine of A cosine B, right? So here you will remain with tan A plus B, which is equal to sin A over cos A plus sin B over cos B over 1 here, it is 1 minus sin of A over cosine of A times sin of B over cosine of B, right? So here also the answer would become tan A plus B, which is equal to sin of A over cosine of A would be tan A, as you have seen above, plus sin of B over cosine of B is also equal to tan B over 1 minus sin of A over cosine of A, it is equal to tan A times sin of B over cosine of B is equal to tan of B. So I think our identity has been proved. Okay, as you have seen here, this is the same as this one. Okay, this is the same as this one. So let's also, okay, now let's also see about cotan of A plus B. Cotan of A plus B. As we know, cotangent is the inverse of tangent. So cotangent or cotan would also be given by cosine of A plus B over sine of A plus B. So we have seen that cosine of A plus B is equal to cosine of A times cosine of B negative sine of A times sine of B, and also sine of A plus sine of B is equal to sine of A times cosine of B plus cosine of A times sine of B, right? So replace the value of cosine A plus B and sine of A plus B in its position right here in this formula, so that you will get cotan A plus B, which is equal to cosine A cosine B minus sine A sine B over sine A cosine B plus cosine A sine B, right? So divide cosine of A cosine B on both denominator and numerator. So that cotan would become cotan A plus B would immediately become cosine of A cosine of B over cosine of A cosine of B negative sine of A sine of B over cosine of A cosine of B over sine of A sine of A sine of B over cosine not here, it is here, it is a cosine, it is a cosine of B, right, over cosine of A cosine of B plus cosine of A sine of B over cosine of A cosine of B, right? So here cosine of A over cosine of A cosine of B over cosine of A over times cosine of B would be equals to 1, and also here, and this would not be reduced. So I think here I think cosine of A and cosine of A would be reduced, and cosine of B and the cosine of B also would be reduced, so that we would remain with cotan of A plus B, which is equal to here we have seen that it is 1 minus sine of A over cosine of A times sine of B over cosine of B, right, over sine of A here, sine of A over cosine of A plus sine of B over cosine of B, right. Then cotan A plus B would also become sine of A would also become 1 minus sine of A over cosine of A is equal to tan of A plus not plus, I think it is times, okay, it is times sine of B over cosine of B, which is equal to tan B, then over sine of A over cosine of A equals to tan A plus sine of B over cosine of B equals also to tan B. So tan of A plus B is equal to 1 minus tan of A times tan of B over tan of A plus tan of B, right. So I think our identity has also been proved. So I think if you look at this point here and this one here, I think it is looking the same. Okay, yeah, I think at this point, if you check this formula which has proved in here, it is also looks like this one. So let's also discuss about Pythagorean Z identities. Pythagorean Z identities. I think we know that if we given a right triangle here, a squared plus b squared, right? So if you divide c on both sides, you will get c squared over c squared equals to a squared over c squared plus b squared over c squared, right? And this would be equal to c over c squared equals to 1. C squared over c squared equals to 1, and this will be equal to a over c squared plus b over c also squared. Now, I think we know that cosine of beta is equal to adjacent side, the side AC over AB, right? And this would be equal to AC is equal to A over C, right? So if you replace the value of A over C with cosine, you will get, so let's first also calculate first the sine of beta. The sine of beta will also be equal to opposite side of the angle B. Opposite side of angle B, I think it is B over AB, right? It means that it is B over C, right? So replace the value of for B over C and A over C with its value in this formula, so that you get 1 which is equal to cosine of beta squared plus sine of beta squared, and this will be equals to cosine of beta squared plus sine of beta squared, which is equal to 1, right? Let's also see about if you divide A on both sides, you will get c squared over a squared equals to a squared over a squared plus b squared over a squared, and this will be equal to, will be equivalent to c squared over a squared, which is equal to 1 plus b squared over a squared. And we know that b over S equals to tan of beta. Okay, and also C over A equals to sec of theta. So that replace the value of B over S and C over A in this formula. I think the answer will be sec squared beta, which is equal to 1 plus tan squared beta. Right? Let's see also, if you divide D on both sides, you will get C squared over B squared, which is equal to A squared over B squared plus B squared over B squared. This would be equivalent to C squared over B squared, which is equal to A squared plus B squared plus 1. Okay, and this will be equivalent to C over B squared equals to A over B squared plus 1. So I think we know that C over B equals to cosec beta, and also S over B equals to cotan beta. So replace this value in this formula so that you get cosec square beta equals to cotan of beta squared, cotan beta squared plus 1 cosec beta squared equals to cotan beta squared plus 1. So I think we have 3 identities, which is called Pythagoras identity. So the first one is cosine beta squared plus sine beta squared equals to 1. The second one is that sec beta squared is equal to 1 plus tan beta squared. That is the second one. Also, the third one is the cosec B cosec beta squared equals to cotan beta squared plus 1. Let me write it clear. Cosec beta squared equals to cotan beta squared plus 1. That is the third one. So I think the most important formula in trigonometric identity is this one, but if necessary we will see how we can convert sum into difference also, and also sum into product or product into sum. So that will be discussed about in the next video. But what I can remember is that don't forget to share this video after watching, and if necessary to make subscribe if you haven't ever. Also you may know that the more you visit Node TV, the more knowledge you will gain, so that your skills will be sharpened with Node TV. Thank you.